A cloud outage?
What? A cloud? Look, super important VP, I promise. We're going to bring it up in just a minute, I promise.
I thought you were the TL of all this. I thought clouds didn't go down. How could it be a cloud outage?
But they're cloud. I mean, they're still compute. Look, this is just really complicated. Let me just push a few buttons, and I'm going to try and bring it up.
A cloud outage.
And see.
So I'm not really a VP.
And I actually am a TL. Hi, my name is Scott. And this is James.
And I'm James.
We are members of the data platform team here at Databricks. And we're here to kind of tell a bit of a story and introduce you all to a few concepts that helps us build in every single region and every single cloud as customer zero on Databricks, every single feature. In our years of working in software, we've always been in the spot where there's been a major outage, and you're on the phone call, and that very important salesperson is here to tell you, like, I need an RCA for my very important customer right now. This is really important. Or that CTO is like, I'm going to run the post-incident review because I want to talk about it. And we want to talk to you all about how to build resiliency and systems into place so that way you can deploy your Databricks workloads, not just in a new region in the same cloud, but in different clouds, different regions, and move workloads from place to place to place on a regular basis. This is what we do multiple times a year for all the new regions. To start, I would actually like to do a quick poll of you all. So I am interested in how many of you all use different clouds. So how many of you all use GCP? Okay, all right. And AWS? All right, wow. Okay, Azure. I promise this wasn't like a sorted list of my opinion on different qualities of different clouds, but this is just how I put it up on the slide deck, I swear. All right, and how many in more than one cloud? Okay. So now I saw a few people with like wavy hands, et cetera, right? I think what I've found to be true, which surprised me when I started Databricks, is that there are actually quite a few customers actually deploy on more than one, but they're kind of like discrete workloads, like different jobs and different clouds. That's not what James and I do. We deploy the same stuff in the same cloud, the same time, every single day. And I'm interested, is anybody else an intrepid explorer like us? All right, that's what I thought. And so I want to convince you all that it's possible, and I want to introduce you all to a few different concepts of what that's going to be like. Okay? So this is an extension of something that we started talking about last year at Summit. We talked a little bit about like our path to Unity Catalog. And Unity Catalog is a clear, important abstraction to the systems that we're building. And in this talk, James and I will walk you through what we've been building since. Something that makes meeting compliance standards easy. Lawyers happy-ish, and engineers as productive as possible. Now, what we did, like we deploy in more than 100 different workspaces. We have workspaces in every single region, a bunch of different regulatory domains, and all these different clouds. And as we sort of started to grow, everyone started adding like little if statements, like, well, if it's AWS, it's definitely this way. If it's GCP, it's definitely this way. And so we found there was an awful lot of friction as new regions came up, which things needed to be deployed in which order, what was the right way to do things. And so we started talking with people and what they're really struggling with and what they actually wanted. And when you talk to them, you always learn so much. Like, why can't I just log into the workspace? That's all I want to do. Why isn't my data there? What data is this? And as we started diving deeper, we started to come up with what we think is like 4 core concepts that really help users get to that point that makes this really easy and fast. So the first one is people always care about which data is available. Now, you may think, well, like I just use Unity Catalog, I search, I can find it, right? Well, you have to have access to be able to see the schema that's there. And we have 100 workspaces. Are you going to search every single workspace to go find it? So we need a way to give people the ability to say, OK, I want to run my job whenever this Unity Catalog table is available, wherever workspace that is, wherever that happens to be. They need to be able to get access to the data. It's not enough to be able to say, like, I know the data's there. Can you please, please, please just click the button and say yes? In Unity Catalog, you can request the owner to say, for this schema, can I please get access to it? And the UI will federate some events back and forth, and the user can log in and click yes, you can get access to it. That doesn't work at scale. It doesn't work with 100 workspaces, right? You can't do that. So we need a way to give the jobs and the teams the ability to run and get access to that data right away, just in time when they need it, right? They don't get access to all the data, right? That would be the easy way out. Just like, OK, you get all the access. But they need to be able to get the fine-grained access they need just in time for their particular workloads. You need to test the changes. In my years working with data teams, this comes up all the time. The staging data is not like the production data. It doesn't have the same velocity. It doesn't have the same shape. It's not quite the same skew. I need to test on real production data. Sometimes it's not even there, right? So we need ways in which we can allow folks to safely deploy their stuff to all these workspaces, all these production workspaces, and do SOAP tests, where they run their job to see if like the RAM, if we need to run on bigger instances, right? Or if there's any regressions. You'll be able to see if the data matches. Then you'll be able to look at 2 different data sets and see if there's any diffs that happen, right? You need the ability to abstract some of that stuff away. And the thing that underlines all this is speed. You need to be able to do this quickly, because if you make this hard, you make this arduous, you make it a JIRA ticket. They have to file and they have to walk themselves through it. And if they do it every single workspace, this just isn't going to work. So it has to be fast. Everything has to be fast, 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 fast. Okay? It's also important to hear what they're not asking for. They're not asking for VPC configurations. They're asking for IP ACL lists, cloud nets, VNet setups, IAM roles. Well, sometimes IAM roles. Sometimes they're just like, yeah, I want this God role. Why can't you just give it to me? They're not thinking about vacuum settings. They're not thinking about like predictive optimization, which can be really powerful when used the right way, right? They're just not thinking about these things. It's not because it's too hard. It's just not something that comes in their brains. Right? What they want to do is they want to just understand and transform the information that is there. That's it. It's not that they're not smart enough to care about cloud nets or VPC settings or IAM roles. They just don't have enough time, right? Their brains can only fit so much stuff in their heads. And so we really need a platform that automates the way for over 100 workspaces in all these different regions. We need to be able to automate it away so that way we can actually move them from one place to another place, which is something we do on a regular basis. We move jobs from different places so that way we can get access to different quotas, different resources, different other things. All right, so this is hard. The details of all these clouds, they matter. AWS is subtly different in different regions even, right? Like, there's one region that requires you to set up an SDS endpoint. Look, I don't know. Sometimes you need to make sure you have the VPC endpoint set up the right way. Is the S3 bucket in a different IAM account? If it's in a different IAM account, does it have the right bucket policy that allows me to do the stuff I have to do? Is it SNS, or should I use SQS in this region? Does event grid work in Azure in this spot? Look, don't get me wrong. Like, all this stuff is interesting. I just don't want everyone to have to think about it. I want to automate it away. I want people to be amazed that all I have to do is tell me about it, and then I figure it out for them, right? Databricks provides some of this stuff, and Cloud Provider provides some of this stuff. The workspace setup gets you what users want. They want SQL endpoints. They want job scheduling. They want notebooks. Unity Catalog gets me what I want. I want to be able to restrict what jobs can access which things, what humans can access which things, service principals, cloud identity mappings, all this stuff Unity Catalog gives me. It gives me a nice abstraction for. Cloud providers give me a whole lot of buckets and the VMs and the different configurations and quotas. But what I need, and what we've been building, is something that blends all these things together. It's able to look holistically at all these different cloud accounts, at all these different Databricks accounts, at all these different workspaces, and make sure that each job that lands in these places has the right things, the right access control, and it can do it fast. So that is what we're building. Now, this is hard, and it's a little scary. We've been doing it for a little bit. There's been a lot of rough edges. We've learned an awful lot. And I've been lucky enough to actually work with James, who's up here with me, 2 different companies. And so he's going to walk us through what we've been building and how we think about how that stuff works.
Thanks, Scott. It's sort of funny. Scott mentioned an issue that happened in the build just a couple days ago. It's like, yeah, I recognize that. These are real things that happen. So our journey on this starts with our story of what became challenging for us. So we started out, and part of what we do is we run in every region that Databricks has a presence in, and that list is continually growing. When we started out, it was a day to set up a new region, because it was a handful of jobs that was supporting a particular use case. And then we supported more use cases in more regions, and then it took 2 days, and 3 days, and 5 days, and 2 weeks. And that cost, that operational cost, beyond any financial cost, just started adding up. And we just couldn't keep up with it. We couldn't dedicate person weeks of time every quarter just to bring up new regions. So we tried to ask, how can we make scaling free? How can we remove this cost that was incrementally added with every single workspace and make it so that when we brought up a new workspace, it was free. When we had new workloads that needed to run on every workspace, it was free for us operationally, and also very cheap for our customers, for the data platform. So we're starting, as Scott mentioned, on top of the Databricks platform, doing Databricks on Databricks. If we weren't, we'd be spinning up VMs, we'd be setting up IAM policies, we'd be putting them in Kubernetes clusters, we'd be running Spark, we'd be doing scheduling on Spark. There's a lot of things that Databricks gives you, an abstraction over these different clouds that lets you have a standard definition for what a job is, where it runs, how it runs with a schedule. But what we found is that that wasn't enough to make it easy for our customers. They were still having to think about where they ran and what the particular configurations were. And since things change all the time, they'd be like, okay, I need to roll out a change. Okay, that's a quarter-long migration to make a change everywhere. That was just too expensive for our customers too. So how do we go about making scaling free with Databricks at Databricks? What started with this key recognition that they're the two things that customer wants. They want to know what data is there, and they want to be able to define work that acts against that data. So let's dive into the data registry, the first part of this. So the data registry has 3 parts. The first part is the data type. So you can have documents that are, say, a bucket. You can have tables. You can have streams. You can have other sorts of primitives as they roll out. And so that defines like what the data is. And then on top of those, we have the data taxonomy that annotates within that particular data set what sort of data is it. And this taxonomy is a whole other talk itself, but it talks about what it is and then what purposes can it be used for. Can it move across regions? Does it have to stay in that region? Can it be accessed by certain types of jobs but not other types of jobs? This taxonomy defines what our obligations are, mostly from a compliance and legal perspective, but also more broadly in how it gets handled. And then the third part is the actual instances of the data that live in different places. So if you've got something that's a particular type of log, you don't want to track all those differently. You want to say, I have this log in this region, in this region, in this region. And then on top of that, you want to define a workload against it. So that workload has the dependencies of what it inputs and outputs. It has the artifact that allows you to do that processing, and that can be notebooks, it can be jars. We have a lot of jar jobs. It can also be SQL. And then in addition to that, we have the people who are defining these workloads define the dependencies. So things like secrets, they need to access APIs. Things like IAM roles, they need to access data or other endpoints, and also the networking requirements. So sometimes, often in our case, there's queues that are only accessible via private networking. And so for that job to run in a particular place, that networking needs to exist before that job is run. So you saw a single definition of this. This is a definition of how it federates out. So you would have a particular set of tables that in every region were transformed into their other table, and then you have another workload that collects all those together and has another output. So for things that need to stay in region, they stay in region. For things that have compliance requirements that are allowed to move across regions, they move like that. So we've got this idea, and it's a nice abstraction. The first problem is, where does it run? And that's where we came up with the idea of baseline workspaces. So as part of the first part of this operational challenge that we were originally seeing was that we had created workspaces, and each workspace was created at the time it was created with the defaults that happened to be the defaults then. And if you ever wanted to update these, it was a migration. It was a project that could be a quarter long. It's like, let's turn on Unity Catalog. I know a lot of people are still facing that migration. That was a significant level of effort. And so we saw that this was going to happen, going to keep happening. And we decided that we need to make it so that this was free to scale. So in building that, how do we want to expose it? So the first thing we want to have is a use case, and that's the core. And it's sort of a vague idea, but the idea is that when you have a group of things that have a similar purpose and are going to be subject to similar compliance requirements, you call that a use case. And so when someone wants a use case, that means that they're going to be responsible for owning the budget of that use case. That means they're going to be responsible for owning the administration and like higher level business compliance requirements. But we wanted to make it easy, and that's where we came up with this definition. All you need, an owner, a use case name, a use case description, and who pays for it. And what this does, underneath it, it says, okay, that goes everywhere by default. If you're going to get a workspace that you can run your workloads in everywhere, that we have a managed footprint. And if you want to control it, there's options like this, where you say, in prod, I want it everywhere, but for the staging version, I only want it in these 3 regions, and then in GCP, I need it in all regions. So we had this opt-in complexity that we added to this interface so that we could keep it simple for the people who want it simple and add those options for the people who didn't. So how does this actually go together? What are the actual phases of building this? Well, the first phase is the cloud account phase. And where does this workload actually run? It runs in a cloud account still for non-serverless workloads, which we have a fair number of. So what do you need to have a cloud account that can support baseline? You're going to need service accounts for some clouds and not others. You're going to need the IAM roles that Databricks uses to manage resources in that cloud. And one of the other things that we looked at as we were looking at how to make scaling free, we thought, what if we just pre-allocate all the metastore storage? Saves us time later. Empty storage doesn't cost anything. So that's what we do. We do pre-allocation. After you have a cloud account, you have a Databricks account. And this Databricks account, our interface to this is a little bit different because we have a button that we click to get a new account. But it's still a process of making sure that that account that's associated with that particular use case is set up to our baseline standard. That baseline standard starts with unified login. So that has some cloud variation as well. But unified login allows you to log into the account and be able to access any workspace in the account that your user has been assigned to. And I'll talk to you about how that actually works in a couple slides. We manage all this with service principals. We don't want any kind of user-based or service account-based way of configuring these. So we provision account admin and metastore admin service principals that are the credentials that are used to manage this. And then we also have this concept of account grant groups. So what these groups do is they provide a place for you to incorporate a just-in-time group. So there's a whole set of things that we actually do. But what we want to do, and what we do, in fact, do, is make sure that there's no one who needs standing administrative access to anything, ever. Everyone gets the access when they need it, with a justification for getting that access. So if you need account admin, you can get it. But you get it through this group that's dynamically updated with the people who have requested and gotten approval for this. And there is also the account group set up. So we also have a standard for importing accounts from our identity provider that we then use for assigning additional permissions to particular data sets. So those need to be set up. And then other defaults, like network policies for serverless, compliance security profiles, and of course, IP ACLs. And if you had taken the shortcut to pre-create all the storage, you can also pre-register all the meta stores so that those are available to you in a single pass in a handful of minutes. So we've got an account that's ready to support baseline. Now we need to build workspaces inside of those. But those still have their own set of prerequisites. And a lot of this is basically in the Terraform documentation. If you need to go through and actually read how it's done, there's in each cloud's version, there's a layout of this. But you need a place for the compute to run and networking. You need a NAT gateway still for most people. And then we also set up private link for the cloud service provider endpoints, as well as the Databricks endpoints, so that we can use the internal and not go across the internet for our, it's called Secure Cluster Connect in 2 of the 3 clouds. It's called something else in the 3rd one, but that's the idea. So when we have those cloud ones, we also need the Databricks resources. That's the workspace admin service principal, the workspace admin just-in-time group, and the workspace access group. So I talked about how with unified login, you log in one place. You don't have to set up SCIM in every single workspace, which does not scale. The workspace access group, when you assign that to a workspace, the people in it get access as a user. And so then we use the same process of including another group inside of that group that's provisioned by the identity provider that allows people to get access to that workspace when they're part of that group. And then you create the workspace. That's quite fast, actually. And you go on to then the phase after that, which is assignment. So you can't do these things until the workspace exists. And then once the workspace exists, you assign a metastore to it. There could already be a metastore in that region, in which case it's not a new one. If it's a new workspace for that region, then it's a new metastore. You assign the workspace administrator security principal, the just-in-time groups, the access group, and you can also then assign the network policies for the serverless egress gateway. So we've been talking about the operational free part. We haven't talked about the security part of it. And so this was one of the tricky things for us because we had policies, they were written in words, and it was unclear how those words mapped to actual API calls. And if we wanted this to run, and we did want it to run continuously, to be able to assert that everything was still matching, we had to turn those documents into something that we could actually say, this is the setting in the API, and we have verified that that setting is set. So we had long conversations with both legal and trust and safety engineering, and got the actual list that we apply. So that comes to the security and compliance phase, that we do these settings inside the workspace. So these are some of the settings that we do. There are a couple others too. Disable HMS, disable DBFS, disable support access, because if Databricks is accessing Databricks on Databricks, it should be through the product and our management, not through support. We enable verbose audit logs. We enable all system tables, because they're invaluable for understanding what's going on in the environment, including having the exposure of the audit logs. And we still, I wanted to have this not be on the slides, but we still have PAT tokens in some cases. We're trying to get all the way over, but we do assert a lifetime setting on those so that they have a specific maximum expiration. And then we also set the workspace ACLs. And then after that, because it is security and you trust but verify, we have a separate implementation written in Python. So Terraform says it's all done. We're going to check in Python every one of those settings and then generate a report that says, yes, this workspace has met the security compliance requirements. And then be able to provide that to anyone who wants to make assertions about the state of the workspaces. And then we hand those over. So in many cases, we hand the workspaces over to ourselves, which I'll talk about the workload side of it. But we can also hand these over as their own product to other parts of the organization. So if IT needs a workspace, they shouldn't have to do it from scratch. If HR needs a workspace and they do it from scratch, it's a whole I mean, all these things I've just been talking about, it's a whole bunch of things that you need to know. So we also support handing these over. And what that means is they get account admin, they get Metastore admin, they get workspace admins. For the places that require it, they get the CSP service accounts. But we also retain our separate set of these that are audited, attributable to us, so that we can continue to assert the correctness of the configuration and update it as additional controls become available, as the security requirements evolve. So that's how you do it. You have to make this process something that you can run over and over and over again, and so that it continuously converges on the state that you want it to be in. But there's one more tricky part here. I don't know how many of you work with Terraform on a regular basis, but Terraform saying that something is still in the same state that it should be in is not the same as Terraform actually taking the action to create it. So we add a separate process that takes a workspace, brings it up from scratch, and tears it down from scratch in every cloud and every regulatory domain. Because it's possible, it has happened, that some policy changed and the create part of it doesn't work anymore. We want to find that out right away, and not when we actually have to bring it up to meet some deadline. So that's how we add this additional process to make sure that we can continue to be able to scale anytime we need to. So we've talked about making workspaces free to scale. Let's talk about what it takes to make workloads free to scale. And that's a lot of the stuff that Scott was talking about before about what users want. There's two different kinds of scaling here. There's federation, and this is what people talked about for a long time. So in our particular case, it may be different for you all, but federation is a big part of what we do. We bring up a new region, we need to run one more of all the workloads that need to run in every region, in that new region. And so there's a whole long bring-up process where lots of people have to make changes to their code, and they have to deploy that code in a particular order so that the data is available for the people who came before them. And we wanted to make that free. We wanted to make it so when you bring up a new region, a new data set was available in that region, your stuff just runs. But there's also portability. And this was something that we needed to be successful as a platform. So when people are running these workloads, you may need to change something if you're a platform provider, which we are. So say there's a different way that fundamentally Databricks workspaces get set up. It's happened a few times. And you can't make that change on running workspace. Maybe it will never happen again, but we needed to make sure that even for some of the settings that can't change, that we could take their workload, move it to a new workspace, and they would have to make no code changes for that to happen. That could be to free up capacity, that could be for whatever else. But as long as every workload that runs is hard-coded, look up what workspace I'm in and run with these settings, it's not going to work. So we also need to achieve portability. The process to do this had two parts. The first part was figuring out how to actually put workloads in the place that they need to be in at the right time. And that is called the placement platform. The first step of that process is figuring out where it can run. So we have those annotations on the different data types, and those say, if you're going to process this workload, it needs to be handled here. And so here can be more than one place after you have these baseline workspaces, but you subset all the workspaces everywhere that could be run, and you say, this workload can run with this particular set of workspaces that meet the particular requirements in the data taxonomy. And then of those, you can make choices about which has the most capacity, which has the lowest cost, all these other sorts of things. The second part of it is just-in-time dependency fulfillment. So you could, in theory, say, hey, we're going to put all the dependencies everywhere, and then no one will have that problem. But that would be complicated to maintain. Instead, when we have selected a workspace, we have a process that goes through and says, okay, is the data set it needs actually present in that particular workspace? So that could mean attaching metastores. That could mean doing delta shares. That could be means setting up credentials to be able to access different streams. But all this allows us to, when we have placed the workload, we know that it will run there. And the output of that is where those things are actually in that workspace. So the problem that you run into, that you may have run into too, is when you run these things everywhere, you end up with this giant config file that says, this region, this string, this region, this string, this region, this string. Still sort of have to do that, but we want to do that for them. So that when we place something in a particular place, we say, this is where we put this data, this is where we put this credential, this is where we put this access process. And so then all that information about the particular settings for that workspace goes back and gets handed to the workload runtime. So this is the hard part of this entire thing. The workload runtime is what provides an abstraction for the workload that lets it access its dependencies semantically. So instead of saying, I need to access this data set, this catalog and schema and table, you say, I need to access this data set. So it looks like this. You say, I want a data frame. You don't say where, you just say, I want the data frame for regional usage logs. And then we, underneath that, because of how we've placed it, we can give you something that's portable. The same for a secret. I need the secret to the SaaS. Where is that secret actually? In the secret store? When secrets are available in UC, when secrets change again, doesn't matter. They ask for a secret, they get a secret. That's the right one for that environment. And I don't know if you have streaming things that look like this, but if you do autoloader, that's where it can really become long, where you have all these different options that change in every region. So underneath that, we just say, read stream, load my input, and that's it. So putting that all together, we've provided federation and portability while giving people the thing that they need. They want to talk about their data, and they want to talk about their workload. And underneath that, we do all the rest. Back to you, Scott.
All right. Thank you, James. So, I hope to leave you all with, at the end of this talk, with a little bit of an inspiration, right? Probably can't copy and paste everything we did. Probably don't want to. I mean, who wants to run hundreds of workspaces in all these different places with all these different panes? But what I'm trying to leave you all with, I'd love to leave you all with, is a bit of inspiration. Think about who the users are and how you might be able to help them move around in different places. We do this all the time. We've moved major workloads from a different workspace in the same region into another workspace, another region. We do this all the time. We did it last week. We work really hard to make sure this stuff happens. And so what we care about very much is making scaling free for our users and automating away a bunch of the different parts and pieces that matter, but only matter to those of us that are in platform. We really want to avoid people having to write a bunch of big if statements in their job configurations. We like people to really kind of avoid the sort of magical Spark configurations, right? We've all run into it where there's Spark configuration / Jira tickets from 4 years ago that set this Spark configuration, right? We want to help people avoid some of those things. So thank you all so much for attending. I know this is at lunchtime, and I deeply appreciate all coming. Please fill out a survey, and James and I will be off to the side here if you'd like to ask us any questions or anything like that. Please, thank you so much for coming. Thank you.